Okay, here's the video for Unit 8, Day 3, and I'm going to try to go kind of fast. This is kind of a lengthy lesson, so I've written a few things down. You may need a pause at some point if you need to catch up. A lot of my calculations I have ahead of time, so if you want to stop and make sure you're putting in the calculator correctly, it'd be a good idea to pause it, type it in, make sure you're doing it right. So I'm going to go kind of fast just to keep this video to not get too long. So first off, geometric. So we talked about geometric is when you're multiplying by the same number every time to get the next number. So the definition is a sequence where the ratio, which is also considered the quotient, between consecutive terms is constant. So if you took any term divided by its previous term, you get the exact same ratio every single time. So that's why they call this the common ratio. So that's the common ratio, and we denote that with an R. So going through these, first off, just look at them. Are they geometric? So is there something I'm multiplying every time to get the next number? So from 1 to -6, it looks like I multiplied by -6. Did I multiply by -6 again? Yep, and I'm following that pattern, so this one is a yes. And what's the common ratio? The common ratio, R, is -6. Okay. B, if this is geometric, then 2 times 2 is 4, which means I got to keep multiplying by 2. So 4 times 2 is not 6, so that's a no. That's not it. And then 5 to 15, that's multiplying by 3. Then take 15 times 3 is 45. 45, so this one is a yes, and that common ratio is 3. I'm multiplying by 3 every time. Again, take term divided by its previous term. 15 divided by 3, 15 divided by 5 is 3. 45 divided by 15 is 3, and so on. Over here, divide any, 36 divided by -6, -6. -216 divided by 36, -6. So that's how you quickly can check to see. Now the recursive formula, just like yesterday, a sub 1 is whatever is given. I think we did, no, sorry, I said yesterday, but day 1. So just like in day 1, it's going to be the previous term times some number, and in this case, the common ratio. Okay. Then the explicit formula, sort of like what we talked about yesterday with arithmetic, you're going to start with your first term, and on this one, you're multiplying by the same number every time. So I'm going to multiply by that common ratio, but to get to say the fifth term, I'd have to do 4 jumps. If I'm on a sub 1, 2, 3, 4, 5, and I want to get to a5, that's only 4 jumps. So I'm only going to do this 4 times to get to the 5th one. So it's whatever term you're trying to get to minus 1 is how many jumps you need to do. So that's why it's n minus 1. Example number 2, kind of set this up ahead of time again. It says use the given information, write the recursive formula, then generate the first 4 terms. It might actually be easier to do the first 4 terms and then go back and do the recursive formula, but for this one, or actually no, not the recursive formula itself, but to find a1. So a sub n is going to be the previous term, and in this case the ratio is 4, so I'm multiplying by 4. I know the 5th term is 768, so I multiplied something by 4 to get 768, so I'm going to divide by 4 to go backwards. So that's 192, divide by 4, 48, divide by 4, 12, divide by 4, 3. And now I can finish my recursive formula with the first term. So R is pretty easy, but then finding the first term, you got to work backwards to find it. Same thing here. A sub 6 is 0.375. My common ratio would be 1/2, so I'm going to be multiplying by 1/2. Every previous term times 1/2 gives me the next term. So as I'm saying, what number do I multiply by 1/2 to get here? I got to divide by 2 to go backwards. Multiply by 2 to go backwards. So if I'm multiplying by 1/2 this way, multiply by 2 to come back. So this would be 0.75, 1.53, 6, and 12. So a sub 1 equals 12. Okay, so that's our recursive formula. Now the explicit formula, keep in mind here, I need to write in the first term, I need to write in the common ratio. So if I know those 2 things, I've got my explicit formula. Now the easiest, quickest way to find R, take any term divided by its previous term. So I could do 6.25 divided by 25. I could do 156.25 divided by 62.5 like I wrote here. Either way I do it, I get 2.5. So if they tell you that it is a geometric sequence, you don't have to check to see if it is. Just pick two numbers, divide the second number by the first number. Okay. So in this one, my first term is 25, and that common ratio is 2.5. Okay. So if we want to find the 15th term, I'm going to take this to the 15 minus 1 power, the 14th power. And I've worked way ahead on this to speed up the video, so you just may want to practice putting that in your calculator. Maybe pause this and see if you can put it in correctly. Yeah, so that would be your 15th term then. So a pretty big number, and it's going up pretty fast, so that makes sense. That's a pretty large number. Now here, this is going down. It's becoming a very small negative, so my final answer is going to be probably a pretty small decimal here. But to find the ratio, since I know it's geometric, I'm just going to pick any two. So I'm going to take -4 divided by -5. That's 0.8. So my first term, -5, my common ratio, 0.8, into the -1 power. So there's my explicit formula. And then plug those in down here. So the 14th power, because 15 minus 1 power, I get -0.22. And that one I think you have to round, so just go to a couple decimal places, do whatever MathXL says to get it to accept your answer. Okay? Backside. Yesterday we did arithmetic mean. Arithmetic mean is just simply the average, just like how you know it. Geometric mean is not. And remember, the geometric mean, the idea is you're trying to find the middle number between two other numbers. So if I'm multiplying 20 by something to get this number and then multiplying that by the same number, it won't fall in the middle. It's going to have to be a multiplier somewhere in there. So again, the idea that you're trying to find some middle number here. The a sub n is going to be the square root of a sub n minus 1 times a sub n plus 1. So if you want to find this middle number, multiply these two together and square root, and that gives you the middle number. So for this one, if I'm trying to find that middle number, it's a square root of 20 times 80. Okay, so I get 40. You just check it. It looks like r must be 2. So 20 times 2 is 40, 40 times 2 is 80, it falls right in line. 40 is not smack dab in the middle between 20 and 80, because 50 is. That's because it's not arithmetic, it's geometric. Okay. So over here, again, just using your calculator, if I want to find that middle number, it's a square root of 3 times 18.75. Okay, so this one, put it in my calculator, 7.5. Okay, again, not supposed to be right in the middle. It's supposed to be a multiply 3 by the same number to get this, then multiply by the same number, and we get that guy there. Okay, so kangaroos. Again, I know I'm going fast, so at any point, if you need to pause, pause. I'm just trying to get this. I like to keep them between like 10 and 12 minutes. So the kangaroo population of Kangarooville is increasing 35% every year. So in 2014, again, think of that as A sub 1 is 2014. There were 40,328. Write an explicit equation. Remember, to write the explicit equation, all I need is the first term and the common ratio. That's all I need. So A sub n is going to be 40,328. And now my common ratio, it's increasing 35%. So if I just put 0.35 in here, that's not increasing. I'm going to have a smaller number. So after 1 year, I'm going to have 35% of what I started with. That's a smaller number. I got to make sure I put a 1 in there. So it's increasing by 35%. That means the 1.35 is my common ratio. And then n minus 1 power. So there's my explicit formula. Write a geometric sequence representing the number of kangaroos. So again, 2014 is A sub 1. That's 2014. So we got 2015, 2016, 2017. So I got to plug 1 in. And when I plug a 1 in, well, that's your A1. I don't need to actually plug 1 in. Now plug 2 in, so it would be 4328 times 1.35 to the 2 minus 1 power, or the first power, and you get 54,443. On this one, I'll plug a 3 up here, so I'm going to end up squaring it. So it would be 4328 times 1.35 to the second power, because it's a 3, so subtract 1 from it, and that gives me 73498. Plug in a 4, which means I'm going to be cubing it, and it'd be 99222. In what year will it be 1 million kangaroos? So we don't know what year that is, but I want that to be a number in my sequence. So I'm going to plug that in on the left side. And I know you hate this, but this is one of those where a logarithm is helpful, because my variable is in the exponent and I want to solve. I'm going to divide both sides by 4328. So now that's gone. And then I'll take the log of both sides. And since this variable, or the variable's up here, is going to come out front, I'll end up dividing by log 1.35. So I'm not really updating. This is going to be a decimal, and you can put that in the calculator if you want. That's up to you. So now I've divided log 1.35 over. N minus 1 equals this, so really I just need to add 1 to this, and that equals n. So this guy right here, you can, whatever way you want to put it in the calculator, if you simplify all this, n equals 11.7. So that means during that year, we have to go to the kind of the next year to get it all the way up there. So that means n would be 12. So what year would that be? Well, remember that year 1 was 2014, year 2 was 2015. So if we count up from there, so 12 later, and 1 year later is actually 2. Okay, so if I go to 12, that's going to put me up to 2025 would be the year that it happens. Okay, so basically add 12 and then subtract 1 from it, because if I add 2 to 14, I get 16, subtract 1 to get 15. Okay, if I add 3, 2017, but subtract 1 to get the actual year, because the first one doesn't count, because 1 is 14. So last one, 781,250 is what term of the geometric sequence 2, 10, 50, 250, what is the value of n? So if I'm looking at this, my a sub 1 is 2. My common ratio, pick any two of these. So 50 divided by 10 is 5. 10 divided by 2 is 5. So that's my common ratio. So I got a sub n equals, sorry, my light just turned off on me. If I sit still too long in my classroom, my lights turn off. 2 times the common ratio n minus 1. And this is one of the terms, so I'm going to plug that in over here. So 781,250, that equals 2, and 5 to the n minus 1. Divide the 2 over. So I've got, and I can divide that, that's 390,625. And now variable is in the exponent, so log both sides. Pull this out front, divide by log 5. And then again, to n by itself, add 1. So I'll just put a plus 1 over here. So all of this equals n. That means if I put all in the calculator, and this divided by this actually is exactly 8. And then add 1 more, it'd be 9. That's the 9th term. So a sub 9, or if they want the value of n, is 9. Okay, so hopefully that video wasn't too long, but you may need to go back, listen to it a few times, pause. Yeah, so you have a Math Excel assignment, and that's posted on the agenda. Thank you.